So here was the problem in your homework. It is 18F4, I think. And in this problem, there was a proton which would fly into this field as shown over here. Eventually, because of there will be a force, electric force acting on this proton. The proton is positively charged, then the direction of the force will coincide with the direction of the electric field, and the force on the proton will eventually hit the lower plate. What we need to find delta x in this direction. Okay, very good. So delta y is actually given over here. Okay, it is minus r because the proton goes down. Okay, and r is what's shown on this figure over here. Okay, so what we know, a couple of things. But before we do go there, actually, let me discuss something else. So there was a very similar problem in Physics 211. As a matter of fact, I think you can also find a problem where you have a cannon, okay, and the cannon releases a ball, and this ball goes up and goes down, eventually hits the ground, and you need to find how far this cannonball went. So this problem was in workout examples, and you can find in this 212 problem, it was, I think, 0 something in worked out examples. Okay. So, but here we can recognize that this is 2D kinematics. And for 2D kinematics, we have to write first all known kinematic, and unknown kinematic variables. Okay, so let's start from the x direction first. Well, delta x, we don't know, we want to find this. Now, the velocity in the x direction over here is actually known, it's given. Well, I mean, the specific problem, it is some random number, I don't know, so this is this. Okay, but in your problem, it will be a different one. Okay, we know that. So this is initial velocity. Okay, some number, I will call it v0 for now. The final velocity of the ball in the x direction is actually unknown, and we are not necessarily interested in finding it. The acceleration in the x direction is actually known. There is no acceleration in the x direction as there are no forces acting in the x direction. The only force over here is the electric force, as we said, to neglect the gravity. But even the gravity would be only in the y direction, right? So here we have only the force in the y direction. There are no forces in the x direction. And since there are no forces in the x direction, okay, from the Newton's law, we will find that the acceleration in the x direction is 0. Okay, and finally, the time the ball traveled, we also don't know. So we look at this as a set of these 5 kinematic variables in the x direction, and we see that 3 of them we don't know, and therefore we cannot solve this problem. We need more input. Okay, so, and the input will come, and it will come from the y direction. Okay, so let's look at it. So in the y direction, so what do we know in the y direction? So in the y direction, we know the distance traveled, it is minus r. Some negative number, it's given, okay. Minus r. So we know that the initial velocity in the y direction is 0. The proton only had horizontal component of the velocity in the initial state. Okay, so the next, what we know is, we don't know the final velocity, but we're also not really interested in finding it. So what about acceleration in the y direction? Well, acceleration in the y direction we can find using Newton's law, right? So the acceleration in the y direction, ay times the mass, equals to the net force in the y direction. The only force in the y direction here is the electric force, okay, F electric, okay, in the y direction, and we just divide by m. So this Newton law, so from this equation we obtain this equation here. Okay, so now what is the force in the y direction? Well, you already know that the force in the y direction will be given by, well, the charge of the proton in this case, times the electric field in the y direction. So the electric field in the y direction has only y component, okay, and it points down, right? So it's point down, it's opposite to the y axis as I show in this figure, and therefore there is a minus sign in front, and here I write the magnitude of this electric field, and this is given. Okay, so one should not forget about the minus sign over here. Okay, so therefore the acceleration in the y direction is negative. Well, that's kind of clear as well, because this proton will accelerate down and eventually fall on this plate, right? is negative, and its magnitude is given by this equation over here. Okay, very good. So now we need to find, we can find time, this proton traveled this distance. Okay, we can find time. It's unknown, but we can find it. So look at this. So we have in this in this set in the y direction 3 known kinematic variables. No, not this one. The acceleration, initial velocity, the distance traveled, and therefore we can find all other kinematic variables. Yeah? So 3 known, we can find all of them in the y direction. What did I do? All right. So we can find all of them in the y direction. Perfect. So now, but t here and t in the x direction is a common variable. If we would be able to find t over here, we would be able to substitute it into this part of this equation, into this part of the problem, and then we will count. So t we would find. So we would know t, then we would know the initial velocity, and we would know acceleration. So we would also know 3 variables. And once we know these 3 variables, we will be able to find all of them, including delta x. Again, so from the y direction, we will be able to find t. Then remember this t and substitute it into the x direction, kinematic part. Okay, so then this will be a number, this will be a number, well, it is a number already, and this is a number, and therefore we will be able to find delta x. Now you need to remember which kinematic equation, I showed it to you accidentally, which kinematic equation you have to use to find t for the part y. So here you know delta y, you know initial velocity, you know acceleration, you want to find t. So there is one kinematic equation which bounds all these 4 equations together and other unknowns, like for example this one, for example this one would not appear. Okay, so there is only one such equation, and from this you'll be able to find t. Okay, now I actually solved this problem until the end, but I'm not going to show it to you. I will let you continue solving it again. So you find t from here, you substitute into this part, and then you find delta x. Okay.